In this fourth video, we will be discussing about pre-compression, which is the fourth method of ground improvement technique. Pre-compression, achieving primarily consolidation before construction, before application of structural load. Major settlement happens before the construction, suitable for consolidation of saturated compressible soils. Accelerating consolidation happens preloading, shortening the drainage path. This is the diagram of how preloading happens. The original GL, above it a preload is being kept. The deformed GL is formed after few hours. Procedure for preloading: remove the topsoil of depth of 0.5 meter. The base layer of free draining material will be filled with gravels plus sand, approximately of 0.6 meter thick. The pre-load application. Methods of preloading: heaping of filled material, embankment loading, final structural loading, liquid storage tank, pre-ponding, vacuum preloading. Vacuum preloading happens in soft oblique clay soil. 150 mm layer of sand is placed on the surface, covered with impervious membrane. Application of 60 to 80 kilopascal vacuum pressure induced in sand. It acts like the equivalent overload. Rate of consolidation is calculated by time dependent compression. Degree of consolidation can be taken out by the formulas given on the screen. Vertical drains: continuous vertical columns of previous material installed in clay soil. Soil with exceptionally low permeability. Drains provide the path for pore water to escape by traveling the shortest distance. This method of vertical drain is suitable for thick, saturated deposits of clay with very low permeability. This is a diagram of how sand drains of vertical in nature can be used for ground improvement technique in pre-compression. In this, you can see the ground level above which the preload is done. The vertical drain displaces the water from the drains within. Working principle of the vertical drain: drains provide the path of pore water to escape by traveling the shortest distance. Flows in horizontal, that is direction of the least resistance. Concept of radial consolidation takes place. Coefficient of radial consolidation is 2 to 10 times the coefficient of vertical consolidation. Drains collect and discharge the expelled water faster. According to Stanton-Mullus and Kotzia, 1985, lab consolidation on 20 mm thick specification. Primary consolidation happens in 3.7 hours. According to Stanton-Mullus, 1985, lab consolidation on 20 mm thick specimen happens. Primary consolidation happens in 3.7 hours. Second, extrapolating to 6.5 meter thick layer startup, 70% consolidation happens in 16 years, 88% consolidation happens in 43 years. With sand drains, it is achieved in 70% consolidation in 1 month and 88% consolidation in 2.6 months. In this, we can clearly see that if we do a preloading or we do pre-consolidation, the consolidation up to 70% can be achieved in 1 month and 88% can be achieved within 2.6 months, which is way better than 43 months. Types of vertical drain are sand drains and prefabricated PVDs drain. As discussed in the previous slide, this is a typical example of how sand drains are made. The specifications are: diameter of the drains can be varying from 65 to 500 mm. Spacing between the drains can be between 2 to 5 meter. Depends upon the permeability, duration of which consolidation is desired, such that 80% of the consolidation is achieved during the construction of the fill. Depth where N value is greater than 15. Sand: uniform graded medium to coarse, finer than 5% than 75 microns, less than 5%, finer than 75. Particles greater than 4 mm should not be used. Sand should be approximately 1000 times more permeable than soil. Installation of the drains can happen by mandrel method, displacement method, smearing effort, high pressure water jetty, very costly, is continuous flight auger method, which is very economical. So in this slide, we have seen that continuous flight auger method is very economical and high pressure water jetting is very costly. Prefabricated vertical drain is the second type of drains. Initially cardboard drains, now plastic drains are used. central plastic post which contains channel, surrounded by thin geosynthetic turf jacket, 90 to 100 mm wide, 3 to 5 mm thick. Spacing can be achieved at the rate of 2 wick drains per sand drains. These are the photos of drains which are installed for pre-consolidation in a ground improvement technique. Installation, as discussed earlier, specialized equipment stretcher is used, consists of vertical mast to house the casing. Mandrain is hydraulically pushed or vibrated into ground. As mandrain is withdrawn, a wick drain is left in the soil. Installation rate is 0.3 to 0.6 meter per second, as high as 600 meter per hour. Sand wick drains. Ready-made small diameter 100 mm sand drains contained in long filter stockings. Stocking material in high density polyethylene or woven preamble fabric, installed by closed mandrain technique. Controlled variables for vertical drains. The rate of consolidation depends upon the spacing between the drains and the permeability of the soil which is on site. The amount of consolidation happens soil compressibility preload. Monitoring should be done by pre-water pressure and settlement. Application: accelerating the settlement rate of compressibility soil. As the soil consolidates, the shear strength increases due to the reduction in pore water. Used in conjunction with the other ground improvement techniques. Dynamic compaction happens and stone and column. In this fourth video, we discuss the fourth method of ground improvement technique, which is pre-compression, which is done by a preloading and also by the use of the vertical drain. The next video, we will be discussing about the fifth method of ground improvement technique, that is grouting. Thank you and Jai Hind.